Hello children, welcome to Akshara IT Foundation. This is Synop, your maths faculty. Let us go to the today's class. Right. So before going to discuss about the today's class, just revise the formulas or some properties in binomial theorem. So let us revise once, then we'll go to the we'll continue the problems in synopsis 2. Okay. Now mainly if 1 plus x whole to the power of n and its expansion, we discussed that nc naught plus nc1 x plus nc2 x square plus nc3 x cube plus and so on plus ncn x power n. Okay. And also we discussed the general form TR plus 1 equals to NCR x power n minus r. Okay, NCR x power n minus r when y power r when x plus y whole to the power of n. X is the first term, y is the second term. We can take the general form as NCR x power n minus r and y power r. If in the place of 1 plus x plus y, we have 1 plus x whole to the power of n, what is its general form? TR plus 1 equals to NCR 1 power n minus r and x power r. So simply the general form is NCR x power r. Okay. Now let us see the properties here. So mainly the first property, number of terms in the expansion of a plus b whole to the power of n or x plus y whole to the power of n or 1 plus x whole to the power of n is equals to n plus 1. The total number of terms in its expansion is n plus 1 terms. Okay, na? So total number of terms in 1 plus x whole to the power of n equals to n plus 1. Alright. Now let us see the property. We already discussed that, where NCR equals to NC n minus r. And what is NCR? In very starting class we have discussed that NCR equals to n factorial by n minus r factorial into r factorial. Okay, and this is also one of the important property. NCR equals to NC n minus r. Let us go to the next property, that is if NCX equals to NCY, NCX equals to NCY, then there are two options, that is x equals to y or x plus y equals to n. Okay, na? From the same condition, NCR equals to NC n minus r. Okay, they both must be equal or sum of them must be equals to its power, nothing but n. So this is very, very important. If NCX equals to NCY, we have to understand that x is equals to y or x plus y equals to n. Okay, it's highest power. Next property. Let us see the next property. Yeah, that is, and also NC naught, NC1, NC2 are coefficients of the expansion of binomial coefficient like x plus y whole to the power of n. In the instead of writing always NC naught, NC1 like that, we can write C naught, C1, C2 also we can write. So from this, next property is C naught plus C1 plus C2 plus and so on plus Cn. Nothing but these are all coefficients in the binomial expansion. Now I am just adding with them. That means sum of coefficients, sum of all coefficients of the binomial expansion is nothing but 2 power n. 2 power n, very, very important. And also the second one, C1 plus C3 plus C5 plus and so on plus Cn minus 1. Here we are taking only sum of odd coefficients will be 2 power n minus 1. Sum of odd coefficients will be 2 power n minus 1. Same way, sum of even coefficient C0 plus C2 plus C4 plus and so on plus Cn equals to 2 power n minus 1. Okay, na? So sum of all coefficients is 2 power n. Sum of odd coefficients is 2 power n minus 1. Sum of even coefficients also 2 power n minus 1. Okay, na? Right, because while you are observing, while you are expanding, that means while we are discussing about the Pascal triangle, how they are coming like 1, 1, 2, 1, 1, double 3, 1. The same numbers are repeating, right? Or 1, 4, 6, 4, 1. For example, odd terms, if you are counting here, first term and last term odds 1 plus 1, 2, even term, even coefficient is 2. Now here, first one, third one, 1 plus 3, 4, second term, fourth term, 1 plus 3, 4. Okay, here, first term, third term and fifth term, 1 plus 6, 7, 7 plus 1, 8. Here 4 plus 4, 8. So from this we can say that sum of odd coefficients equals to sum of even coefficients. Okay, na? This is also one of the important property. Same way, C0 minus C1 plus C2 minus C3 plus and so on equals to 0. That means nothing but simply even powers or even coefficients minus odd coefficients. We know already sum of even coefficients is 2 power n minus 1. Sum of odd coefficients also 2 power n minus 1. And you subtract both of them, obviously we will get the answer 0. Okay? Right. And most important property is C0 square plus C1 square plus C2 square plus and so on plus Cn square. Very, very important property. This is C0 square, C1 square plus C2 square. Means all squares. Sum of the squares of the coefficients. That is nothing but 2n Cn. Or simply we can write 2n factorial by n factorial whole square. This is the formula you should remember. Sum of the squares of the coefficients of a binomial expansion equals to 2n Cn, nothing but 2n factorial by n factorial whole square. Okay. Now, one more property, that is R into NCR equals to n into n minus 1 CR minus 1. So this one we have already discussed in the synopsis 1, simply nothing but NCR by n minus 1 CR minus 1 equals to n by R. Same condition. This one. Okay. Yeah, here R. N by R. Sorry, R by N. Here R will be, here N will be. Then only we can bring this. It is multiplying. When it comes, it is divided. Same way when you transpose R, that will be divided. So both are same. This is also one of the important property. Right. Okay. So next property, here onwards very important. That is 1 plus x whole to the power of minus 1. 1 plus x whole to the power of minus 1. 1 minus x whole to the power of minus 1. That means until then we have just taken that exponent r. The power is in positive exponent. Okay, positive power. Here onwards negative or fractions. How the expansion will be? Let us check. Same way 1 plus x whole to the power of minus 2 and 1 minus x whole to the power of minus 2. Okay. Now while you are observing here, this expansion will be, see, whenever it is having plus and minus. So plus into minus, minus symbols, no? So alternate symbols. That means first term, third term, fifth term will be negative terms. So remaining all positives, alternate. Plus into minus, minus, right? So plus to minus, plus minus, plus minus, like that will come. First plus, next minus. Okay? That means 1 minus x plus x square minus x cube plus and so on. So plus or minus means 1 having a positive symbol plus, so here minus, plus minus like that will come. Now here minus into minus plus, in its expansion it will be 1 plus x, all plus terms only, 1 plus x square plus x cube plus and so on like this. Now this one, 1 plus x whole to the power of minus 2, here it will be 1 minus 2, here plus into minus minus, no? So plus minus alternate will come. So 1 minus 2x plus 3x square minus 4x cube plus and so on like this. So whenever it is having a exponent is negative or fractional term, there are infinitive number of terms will come. Okay, right, here also. Now minus into minus plus, all plus terms only. So 1 plus 2x plus 3x square plus 4x cube plus and so on. Okay, right. Now in the same way, how can we write 1 plus x whole to the power of n, where n must be a positive, fractional number or a negative number. Okay, now in its expansion will be 1 plus, same like this, nx plus n into n minus 1 by 1 factorial, 2 factorial, here 1 factorial, 2 factorial into x square plus n into n minus 1 into n minus 2 by 3 factorial into x cube plus and so on. Okay, na? So by using this we can derive the general form also. In case if you are taking that 1 minus x whole to the power of n, how we are taking by using this plus minus alternate will come, no? So 1 minus nx by 1 factorial plus n into n minus 1 by 2 factorial into x square minus n into n minus 1 into n minus 2 by 3 factorial into x cube plus and so on. Okay, so from this general term here, we have, until then we have discussed two general terms here. General term is what here? Here general term t r plus 1 is equals to NCR x power n minus r y power r, where n is a positive integer. But here n is a negative or a fractional form. We are writing the general term t r plus 1 equals to n into n minus 1 into n minus 2 and so on, n minus r plus 1 by r factorial into x power r. This is the general term when the n value is negative or in fractional form. Okay, no? So once revise all this, yeah, here onwards, first binomial expansion, NC0, NC1, NC2 like that, where C1, C0, C1, C2, C3 are coefficients. Okay, general form NCR x power n minus r y power r, or NCR x power r, whether it is 1 plus x whole to the power of n format. Now here, number of terms, 1 plus x whole to the power of n is equal to n plus 1, number of terms. Okay, n plus 1 terms will be there. And NCR is nothing but n factorial by n minus r factorial into r factorial. Now NCX equals to NCY, there is two situations, that is where x is equals to y, then only NCX equals to NCY are equal, or x plus y equals to n. Next, C0 plus C1 plus C2, nothing but sum of all coefficients of a binomial expansion equals to 2 power n, or sum of only even coefficients or odd coefficients equals to 2 power n minus 1. Okay. Next, sum of even coefficients minus sum of odd coefficients equals to 0, and sum of the squares of coefficients of a binomial expansion equals to 2n c, anything but 2n factorial by n factorial whole square. Now this is one of the property, r into NCR equals to n into n minus 1c r minus 1, or we can write that NCR by n minus 1c r minus 1 equals to n by r. Next, 1 plus x whole to the power of minus 1. So plus minus you can easily remember, plus into minus minus, so alternative will come plus minus like that. 1 minus x plus x square minus x cube plus x power 4 minus x power 5 and so on like that. So number of terms here, infinite number of terms will form whether exponent is in negative or a fractional form. Now here 1 minus x whole to the power of minus 1. So minus or minus plus becomes, so all are the positive numbers. 1 plus x square plus x cube plus and so on plus like that. 1 plus x whole to the power of minus 2. So here 1 plus minus will come. 1 minus 2x plus 3x square minus 4x cube plus 5x power 4 like that. Here minus or minus plus 1 plus 2x plus 3x square plus 4x cube plus and so on like that. So if n is in a fractional form or odd form, we are writing fractional form or a negative integer, we can write like 1 factorial. That means this expansion will be 1 plus x whole to the power of n will be 1 plus nx plus n into n minus 1 by 2 factorial into x square plus n into n minus 1 into n minus 2 by 3 factorial into x cube and so on like that. Next, here 1 minus x whole to the power of n. Okay? So negative alternate, positive negative will come like that. So general term we can write here. General term tr plus 1 equals to n into n minus 1 n minus 2 and so on n minus r minus 1 terms. So r minus 1 becomes, this minus gives the plus term, n minus r plus 1 term by r factorial into x power r. Right. Okay na? Now let us continue the problems from, I think, yeah, we have completed up to 6 problems, I think so. Yeah, concept based questions, yeah, we completed the 6 problems. That is, the 7th problem is C0 plus C2 plus, if C0, C2, C4 and so on are binomial coefficients in the expansion of 1 plus x whole to the power of 9. So 1 plus x whole to the power of 9, binomial is given, and here C0, C2 and C4, nothing but while you are observing these are even coefficients. Okay, then C0 plus C2 plus C3 and so on. So we already discussed accordingly that C0 plus C2 plus C3, C2 plus C4 plus and so on equals to 2 power n minus 1, where in the form of 1 plus x whole to the power of n. But here we have 1 plus x whole to the power of 9. That means in the place of n, we are having 9. So same coefficient, sum of coefficients will be 2 power 9 minus 1. 2 power 9 minus 1 is 2 power 8. 2 power 8 is nothing but 2 into 2 into 2 like that. So simply when you multiply all of them, you will get the answer 256. 2 into 2 into 2, 8 times. 2 power 8 value 256. 2 power 9, 512. 2 power 10, 1024. Let us go to the problem number 8. The problem number 8 is given that 1 into NC1 plus 2 into NC2. So 1 into C1 plus 2 into C2 plus 3 into C3. Am I right? Yeah. And so on plus n into Cn equals to, so 1C1, 2C2, 3C3 and so on plus NCn. These are all equals to how much? Dash. This value we need to find. Okay na? So let us use that binomial expansion. That means while you are observing this one, we can write this is sigma r equals to 1 to n, because here C0 is not given. Okay na? So 1 to n terms are given, and this one will be in the place of 1, 1, 2, 3, 4 like that. We can use r, because when you substitute r value 1 will come, and I can write CR. Okay. Now see here, this entire expansion we can write like this. In the place of r, if I write 1, 1C1. 1C1 means this one will come. Sigma means sum of. That means first term to n term. First term plus second term plus third term and so on, n terms we should add. So if you are writing the first term, it will be in the place of r, we should write 1. 1C1 plus 2, 2C2 plus 3C3 like that will come. So this entire expansion we can write like this. Okay, no? Right. So that is equals to, we can expand this one as sigma r equals to 1 to n r into cr. R into cr we can write it as r minus 1 plus 1. Can we write r as r minus 1 plus 1? Yes, into cr. So this one I am going to expand like sigma r equals to 1. So this one I am dividing like this. Okay, na? That equals to n r minus 1 into cr plus sigma r is equals to 1 to n. 1 into cr is cr. Okay, let me write. That implies, now while you are observing here, this one, sigma r is equals to 1 to n cr. Cr is nothing but, if you write 1, c1 plus c2 plus c3 and so on n. Okay, na? So c1, c2, c3, c0 onwards, if you continue all the coefficients, it will be 2 power n. So 0 c0 is not there now, so we can write 2 power n minus 1. So in the place of cr, we can write 2 power n minus 1. Okay, because c0 value 1, when you transpose like that, it will come minus 1. Now r minus 1 into cr. That means if you write 1 here, 0 into 1, 0. Next 2. 2 means c2. c2 onwards how much will come? 1 cr, 1 c2, like this will come, right? Do you understand how it is coming 2 power n minus 1? Let me explain clearly in the next page. Right, that equals to sigma r is equals to 1 to n cr, we can write as, first 1 means c1 plus c2, c3 plus and so on plus cn. Am I right? This one we are writing like this. But we know that c0 plus c1 plus c2 and so on cn is equals to, this means the entire one equals to 2 power n. But here we don't have this one c0. C0 value is nothing but 1. C0 value is nothing but 1. So that 1 we can transpose here minus 1. 2 power n minus 1 will come. Okay. Now coming to this one, it is written that, right, yeah, sigma r is equals to 1 to n r minus 1 cr. So I am writing with this sigma r equals to 1 to n r minus 1 into cr plus sigma r equals to 1 to n cr. So previous step I have written. Okay, this one how can we write? In the place of r, if you substitute 1, first term, entire term will be 0. Second term, that means r2. 2 minus 1, that means 1 c2. Okay, plus 2 c3 plus 3 c4, like that will come. But what is the given question? 1 c1, 2 c2, 1 c1 only, no? Yeah, 1 c1, 2 c2, 3 c3, like that it is given. So or else we can, yeah, see here, see the property here, I think, yeah. Where is the property? Right. So while you're observing, see here, one factorial, one, sorry. Yeah. So once observe here this one, 1 into 1 plus nx. So in the place of n, if you write 1, 1x. In the place of n, if you write 1 here, 1 into, sorry, 2 here, 2 into 2 minus 1, 1. So 2 into x square. So same thing we can write, but before that, until then is correct only. But here we need to do some modifications. Like while you are writing here this one, we are writing like r minus 1 plus 1 is given, no? So r minus 1 plus 1, instead of writing that one, we can write in a different manner like sigma r equals to 1 to n, r into, I am just multiplying and divided by n. Okay, na? Here I am, n is multiplying, here I am divided with n into cr. Okay, now see this one, this property, where is this? Yeah, this one, r into ncr equals to n into n minus 1 c r minus 1. Can we apply this property? In the place of r into ncr, we can write n into n minus 1 c r minus 1. That means r into ncr or r into cr. In the place of that, we can write n minus 1 c r minus 1 we can write. Okay, na? So 1 by n will be remains. That means n, in the place of n. Clear? That is equals to this n into this n, I can write front here. So n minus 1 c r minus 1, if you expand like this, it will come n minus 1 c naught plus n minus 2 into c1, sorry, n minus 1 c1 plus n minus 1 into c2 plus and so on will come. Okay, so that equals to n into, while you are observing, all terms are coming here, c0, c1, c0, c1, c2, all are coming. nc0, nc1, nc2 is nothing but 2 power n, but in the place of n, we are having n minus 1, so we can write 2 power n minus 1. So in the place of remaining part, we can write 2 power n minus 1. Okay, na? Great. So next one, I think problem number 9. Yeah, while you are observing the problem number 9, so that is given that number of terms in the expansion of 1 plus x whole to the power of n, where n is not a positive integer. N is not a positive integer, we have already discussed. If n is not a positive integer, means it can be negative integer or it can be in the fractional form. Then we can write this one as it is having infinitive number of terms. That is already I have expanded here. So that is, yeah. See this one, 1 plus x whole to the power of minus 1, how we are writing the expansion, or 1 minus x whole to the power of minus 1 means negative integer, it is giving total number of terms are infinite. It is continue like that only. So from this one, we can write the number of terms if n is not a positive integer is infinite. Okay, na? That symbol is given. So you can check that symbol. So problem number 10. So that is given that. So 1 minus x whole to the power of minus 1, direct formula. So whenever it is minus into plus here, minus plus. So both are negative terms. Minus into minus become plus terms. So all its continuation will be 1 plus x square plus x cube plus and so on like this. So completed. Let us go to the next problem. So I think it is, yeah, exercise 1. So concept based questions are completed. Now exercise 1. The first problem is given that if, yeah, NC1 plus NC2 plus and so on plus, sorry, NC1, NC3, NC5. NC1, NC3 plus NC5 plus and so on plus 2NC, 2N. 2NC, 2N equals to. So this one. But while you are observing here starting, it is starting from NC1, NC2, but ending is given 2NC, 2N format. So let us check that. It is nothing but simply, it is in the form of sum of all its coefficients. Am I right? Sum of all its odd coefficients. Okay. So from this we can write NC1 plus NC3, that means C1 plus C3 plus C5 plus and so on plus NCn minus 1, last before odd one means NCn minus 1. Until here we are having the number of terms is 2 power n minus 1. 2 power n minus 1. And if you start from 2n C1 plus 2n C3 plus and so on plus 2n C2n. Here also will be given that plus, that is 2 power 2n minus 1. Okay, na? 2 power 2n minus 1, because in the place of n it is given that 2n. Okay, right. So this could be the answer, but let us check that options how it is given in that manner. So it is 2 power 2n minus 1, 2 power 2n, 2 power 2n minus 1, 2 times are given, and last 2 power 2n minus 1 plus minus 1. Okay, now right. But here while you are observing here, we can write this 2 power n minus 1 plus 2 power 2n minus 1 I can write as 2 power 2n, we can write n plus n, right? N plus n minus 1. That means 2 power n minus 1 plus 2 power n into 2 power n minus 1. According to the laws of exponents, we can write like this. So let us try to common 2 power n minus 1 from the both of the terms. This will be 1 plus 2 power n. Okay, na? 1 plus 2 power n. So simply it will be okay. We don't need all these things, because while you are continue the terms like this, up to how many terms are there here? 2n terms. Total number of terms will be 2n. Okay. For example, if you take n, total number of terms will be n plus 1. If you take here 2n, total number of terms will be 2n plus 1. So from the direct exponent means odd powers, we can write 2 power 2n minus 1. 2 power 2n minus 1 directly we can write. Okay. So let us go to the problem number 2. If n is a odd term, then nc1 plus nc3. Second one, if n is a odd term, nc1 plus nc3 plus nc5 plus and so on plus n plus 1, nc 2 into greatest integer function n by 2 plus 1 or minus 1, minus 1 here. This value we need to find. Am I right? Okay. So first of all, let us take that let us take the value as, if n is an odd number, so the odd number is in the form of, if n is odd, every odd number is in the form of 2n plus 1. Okay, 2r plus 1, 2a plus 1, whatever. So I am writing like 2r plus 1. Okay, so from this we can write r is equals to n minus 1 by 2. That means except r, I am transposing everything like this. So we can write r term is like that. Okay. So, but we want by 2. So I am just dividing both sides by 2. So it will be n by 2 equals to r plus 1 by 2. Now I want greatest integer function. Apply greatest integer function for both sides. So greatest integer function of n by 2 equals to, in the place of r, I can write n minus 1. N minus 1 by 2 plus 1 by 2. So 1 by 2 is nothing but the value is lies between 0 and 1 because of proper fraction, and we know already greatest integer function of 0.5 or 0 point something is equals to 0 only. So from this we can write greatest integer of 1 by 2 equals to 0. So in the place we can write 0. Finished. Then what is here? Greatest integer of n by 2 is equals to, we have n minus 1 by 2. Okay, na? So let us try to substitute n minus 1 by 2 here. Okay, na? So yeah, sorry, in the greatest integer function of r we can write like this. Directly without, yeah, n minus 1 by 2. So in the place of n by 2, we can write n minus 1 by 2. Now here write, what is this one? 2 into greatest integer of n by 2 minus 1, that is equals to 2 into, in this place we can write n minus 1 by 2 minus 1. 2 cancel, here n minus 1 minus 1, nothing but n minus 2. So this value we found that n minus 2, that equals to NC1 plus NC3 plus NC5 plus and so on plus NCn minus 2. Until n minus 2 terms we should take. That means only the sum of coefficients. Okay, na? Right, that equals to, we know that expansion, right? What is the expansion? 1 plus x whole to the power of n equals to C0 plus C1 into x plus C2 x square plus and so on plus Cn x power n. Okay, so if you take in the place of x, if you write 1, it will be 1 plus 1, 2. 2 power n equals to C0 plus C1 plus C2, 1 square means 1 only, plus and so on plus Cn equals to 1. Okay, na? But here we are taking that only odd terms, so let us take that while you are writing that in the property of NCR equals to NCn minus r. That means NC2 and NC3 both are, or NCn minus 2 both are equal. So from this we can write in the place of C2 we can write NCn minus 1. Okay, NC1, NCn minus 1 we can write. Okay, na? So from this all positives and negatives we can consider like 2 times of NC1 plus NC3 plus NC5 plus and so on plus NCn minus 2. Okay, now this 2 is multiplying when you transpose diverse, so it will be 2 power n minus 1. Okay, now last NCn will be. Okay, now? So 2 power n minus 1, and this one will be NCn or NC0 values are equals to 1. So that one, if you transpose like this, it will be minus 1. So the answer is 2 power n minus 1 minus 1. Okay? Yeah, that's it for today, children. Thank you one and all. Have a nice day. Bye-bye.